Hello everyone. So today's lecture is devoted to another method of reducing the Boolean expressions. So if you have a function given to you, you are supposed to first find out the minimal expression and then prepare the logic gate circuit for that expression. So as we have seen in the Carnot map, it becomes quite difficult uh, when we would. So it is actually we can work with Carnot maps only till 5 variables, and if we have more than that, then it becomes an infeasible solution there. So there comes another method called the Quine-McKluskey method. Here we will do some examples to understand how the method works, and you will get an idea that it can work for any number of variables as such. So let us dive into it, and we will see two examples. One of it is worked out, and I will explain the steps. Another we will take up as the in this live recording session. So uh, whatever we are given with, ultimately we would, as a problem, we would state a truth table. So the truth table would point out those min term numbers which has an output of 1. So it would point out those min terms which for which the output is 1. So here, as you can see, we have pointed out those min terms which are the 0, 1, 2, 5, 6, 7, 8, 9, 10 and 14. So obviously you can understand that it would have at least 4 variables. So 4 input variables. So those 4 input variables are A, B, C, D, and they are written down here. They are written down here. And now let us dive into the technique, how to solve for the how to solve for the reduced expression, minimal expression. So remember one thing, what we are doing is basically we are doing it for the we're doing it for the sum of products expression. Okay, minimal product minimal sum expression, we are trying to find out, which is the most usual case we try to find out. So here you see that what we do, first we list down the those min terms. We list down the sequence, the input sequence. We list down the input sequence for those min terms whose output has been 1. That means we are listing down the input sequence for the min terms 0, 1, 2, 5 like this. So you see 0, 1, 2, 5, 6, 7, 8, 9, 10, 14, and we have simply written down the input sequence corresponding to that. Okay, so here maybe what we should write actually here, this is the min term small m, and this is A, B, C, D. So now you can clearly understand what we have done here. So we only write down those min terms which are giving an output of 1, not other terms. Okay, so now what to do? Now we have several columns, as you can see. So in the column 1 we would collect these min terms in some specific grouping. So we are grouping the input sequence. We are grouping the input sequence, or as you may also say the min terms. We are grouping them in some specific manner. What is that manner? You observe that in group 0, the number of ones in the input sequence is 0. In group number 1, the number of ones in the input sequence is 1. So you observe in any 3 of this sequence you have only one number of 1. In group 2 you have 2 number of 1s in this input sequence. In group 3 you have 3 number of 1s. Accordingly, if you have larger number of input variables, you may have to make more number of groups. So this is the first step. So the step is that you group the input sequences in terms of the number of 1s present in them, and you group it in order. So first group would be group 0, then group 1, then group 2, then group 3, with the corresponding number of 1s in the inputs. And you are taking these sequences from where? From this set, So let me now to highlight things, I am using these colors. From this set you are taking the input sequences. So let us first see where only one group 0 entry, this 0 0 0 0. If 0 is not a minterm, then you would not have a group 0, you start from group 1 probably. Okay, so that is the case. So now you look how many group 1 entries. So this is one group 1 entry. So when you take an entry, you tick it. Okay, so that is something that you should maintain doing. Why, you will come to understand at the last step. So you are ticking it. So when I am taking an entry to group 1, I am ticking it. So these and this. So these are the group 1 entries. Now group 2 entries, number of 1s is 2. So this is 1, this is another one, this is another one, and I write them down. Another one is there, the 10, and I write them down in this manner. Okay, then the group 3 entries, let me see which has been left. This and this becomes group 3. Okay, now actually the step will, that the technique will commence. What is the technique? We have to compare between the input sequences of the adjacent groups, only the adjacent groups. That means G0 and G1, we have to compare the input sequences, and we will notice that only in the adjacent between the adjacent groups there is only one bit changing. Only one bit is changing. You will see, you will notice from the that with respect to this number, with respect to this sequence, in this sequence only one bit has changed. Also in this sequence one bit has changed. In this sequence one bit has changed. So we have ingeniously come to that place where we have adjacent where we have those adjacent ones. In the K-map we had adjacent ones, right, where only one bit was changing. So we have come to that place. Okay, so we can now see those entries for which, so all so remember that all these minterms are giving you a output of 1. However, out of those, these two are adjacent inputs. So that means that when you write them together, the bit which is changing can be omitted. So that is the beauty now. So if you club these two together, the bit which is changing can be omitted. So that is what we will exactly do. So you see, we would try to club the input sequences from adjacent groups and omit the bit which is changing. So you see, we are clubbing 0 and 1. Here you see, we are clubbing 0 and 1, and we are writing it as 0 0 0 0 cross. Okay, that means this bit is omitted now. So we are writing a cross here. Similarly, when you have when you have taken 0 and 1, you should put a tick mark there. So let me remove this, and we will put the tick mark as we go on. So we have taken 0 and 1, and then we take 0 and 2, so 2 is also ticked. So 0 and 2 we take, and then you see the third bit is changing. Then 0 and 1, 0 and 8, then the MSB is changing, so that is X here. So you have to write in this manner. Okay, then what to do? G0 and G1 all combinations has been checked. Now you have to check all combinations in G1 and G2. G0 and G2, you observe between G0 and G2 two bits are changing, but we only need one bit to change. Then we can combine, and the changing bit can be vanished. So that comes from Boolean theorem. So if you have two terms, so some term x and another term y, and you combine it with another term like this, so this bit is changing, y is changing, so you can write it as x only. So the changing bit can be removed basically. So that is what we are doing here. So between G0 and G2 or any sequence which are not in adjacent rows, not in adjacent groups, you will notice that more than one number of bits are changing. So we are not combining the sequences between non-adjacent groups. Also you see that within the adjacent groups, within a group also, if you take up any two sequence, more than one number of bits will be changing. Two bits actually will be changing. Within a group, you will always notice that two bits are changing. Okay, exactly two bits are changing within a group between any two sequences. So that said, the actual technique comes like this. So between adjacent group, you have compared all the sequences, then G0 and G1 you have done. Now you have to do for G1 and G2. So in G1 and G2 you take again 1, so 1 you see 0 0 0 1, and here you see, so wherever there is a 1 you try to match that. So you see it matches with 5 and 9. So you don't have to actually look at 6 and 10 because it does not match the 1 there. Okay, so that 1 has been matched here, and what else is there? A mismatch there somewhere. So you notice that. So then you notice that we have a mismatch here in 5, that the second bit has changed. Okay, so what you have to do, you have to combine 1 and 5 and write it as 0x01. So 1 has been taken again and 5 has been taken. Then again with 1 you have taken 9 also, and you will write it as x001. No other, this 6 and 10 cannot be taken with 1. But then you have 2. So with 2, what you can take? With 2 you see, you observe that with 2 you can take 6 and it will be 0x10. So you again put a tick mark at 2 and at 6 and 0x10. Again 2 and 10 you can take and you write x010. Okay, what else? 2 cannot combine with anything else, but what about 8? 8 you see, 8 you observe it can combine with 9 and 10. So again you put a tick mark at 8, 9 and 10. So 9 and 10 you write down here like this. So after that you have to combine G2 and G3. So all combinations of G1 and G2 are over. Now G2 and G3. So for G2 and G3 you see, you can search from here this way also, you can search from this way also. So this is less number of terms, so I am searching from this way. So you see the 7 will combine. So so here you see that 7 will combine with 5 and no, nothing else. No, with 6 also. With 6 also there are 0 1 1 is common and 1 0 is not common. So you see 5 7 and 6 7 is coming here, and you will put a tick mark. The tick mark is very important. Okay, and then 14 you see it goes with 6 as well as it goes with 10, and with 6 it is x110 and with 10 it is 1x10. So you can read from this way or this way, whichever you are comfortable with. Probably it is easier to always read from this in this direction. Probably it is easier if you read in this direction. Okay, now the next thing, let me move the arrows. So you have formed the column 2. Okay, you have formed the column 2. So in the column 2, you actually after you have finished the grouping of G0 and G1, you would put a line like this. Okay, so these are the combinations of G0 and G1. These are the combinations of G1 and G2. So you put a line here, and then these are the combinations of G2 and G3. Okay, so just for sake of understanding, these are the combinations of G1 and G2. These are G2 and G3. These are G3 and G4. So we have formed the column 2. Then we would try to form the column 3. So in the how we form the column 3, again the same way. So you have a group here, above this line you have a group, and below this line you have a group. Similarly, you have a group above this line and below this line. So you compare between these groups. Compare between these groups. So you see 0 1 is 0 0 0 x, and which among these will combine where there is a x at the last. One has to have a x at the last, right? So that matching should be done with the x. So you see only 8 and 9 can match, and you now check whether only one bit is changing between the rest of the bits. So you see 0 0 0 and 1 0 0. So yes, one bit is changing, which is the MSB is changing. So now you combine 0 1 8 9 and write them as this x00x. Okay, no other combinations for 0 1, taking 0 1 is possible. So also put the tick mark here and here. Then with 0 2, you see where the third entry is x here in 8 and 10, and whether the other bits which are there, among them only one bit has changed. Yes, only one bit has changed, this one. So you would have x0 x0, 0 to 80 is x0 x0, put the tick mark. Then no other combinations with 0 2. With 0 8, the first bit is x. So you see here these two are having first bit as x, but all these two are having only one more bit changing or not. Yes, 0 0 0 0 0 1. So this can go with it, and we write 0819 x 00x. So why I have crossed I will tell you later, but this you have to first write x00x. Then it goes with 210 also, so you put a tick mark here also, and x0 x0 you have got. Okay, so no other possible combinations are there. Okay, please note that no other possible combinations between these two groups can be made. So now you look at the next two groups, next two adjacent groups. You start with 1 5, x is in the second position. You note where x is in the second position, in 10 14. But are you able to combine 1 5 and 10 14? No, because in the rest of the bits you see more than one number of bit has changed between 1 5 and 10 14. These two groups, between 1 5 and 10 14, more than one number of bits has changed apart from this common x. So you cannot combine 1 5 and 10 14. Then you look at 1 9. 1 9, this is one x is here in the first position. In 614 you have a x in the first position. Can you combine 19 and 614? Again the answer is no, because among the rest of the bits more than one number of bit has changed, so you are not combining them. Then 26, the second bit is x, again 10 14. So let's see 26 and 10 14. Can you combine? Yes, we can combine, because among the other three bits only the first bit has changed, you notice. So you can combine 26, put a tick mark, 26 and 10 14. So you put a tick mark and then take this combination here and write it as xx10. So after that 26 is done. 210, you see the first bit is crossed. 614 first bit is crossed. Whether you can combine, you check. Yes, only one bit is changing, so the second bit is changing. So 210 614 is xx10, that you write down. Okay, that you write down first. Among the others 8 9 the last bit has changed. Here 6 7 the last bit has changed, but you cannot combine because more than one number of the remaining bits are changing here. 8 10 you have the third bit changing. 5 7 you have the third bit as x. 8 10 you have the third bit as x. 5 7 you have the third bit as x, but you cannot combine them because more than one bit has changed among the rest of the bits, so you cannot combine them. So you write it, you don't have any further combinations. So now you notice, okay, 614 I had taken one, so I have to put the tick mark, so don't forget the tick mark, otherwise things will be wrong. So 210 and 614 I have taken and I have put the tick mark here. So now you look at column number 3. So now at column number 3 you notice that this particular combination x0 is already there above. X0 is already there in the same group, okay. I have put this line. I hope you understood when I have put this line. After I have finished all possible combinations of the first two groups of column 2, then I have put this line. So now in column 3 in the first group, you notice which are the repetitions. So these repetitions will start occurring as you move in the columns. So the repetitions you cross out. Similarly in the second group you see there are only 2 entries, but both are repetitions, so one of the repetitions you can cross out. And after crossing out the repetitions, then you observe if you can formulate a column 4. So to form a column 4 you have to have a entry in so to match with this you have to have an entry in column in group 2 which has x in the first and the last positions, but we don't have such an entry. Similarly for combining with this you have to have a x at the first and third position, but we don't have a sequence like that in the second group, so we cannot combine anymore. So when we cannot combine anymore, our exercise actually completes here. So this column making of the columns, that exercise completes. Now after completion of this exercise we have to notice one thing, and that is why the tick mark was important. We have to note which of the sequences have remained unchecked, which of the sequences have remained unchecked. So obviously in the last column all the sequences will be unchecked, otherwise it would not be the last column. So in the last column all the sequences would be unchecked. However, in the previous columns also some sequences could be unchecked, and that is why the checking of the sequences was important, because you want to separate out the unchecked sequences. So these sequences were unchecked, so they did not combine with any other term. In column 1 basically all will be checked. then these are the unchecked sequences. So we have identified the unchecked sequences, and that actually gives you the final answer. Now you have to take these terms, here and sum them up. That's all that is to be done. And you see what that is exactly what we have done. So we have started from column 2, and in order we have gone. So the first term is what? This is the position A, right? A, B, C, D. So A is 0, so A dashed, then C dashed, then D, then you have 5 7. You see A dashed, B, D, A dashed, B, D, then A dashed, B, C, A dashed, B, C. So the X you are not considering, the whichever variable is crossed out, you are not putting it in the term. In the column 3 you see, you will only have B dashed, C dashed, B dash, C dashed, then B dashed, D dashed, B dash, D dashed, then C, D dashed, C, D dashed. So you have got the minimal sum expression. So I hope you understood this method, what to do, and let us now do an exercise with Mcclaskey method. Let's take a 5 variable example and let's see. So I am taking an arbitrary one. I don't know, I don't have it in my rough copy. So let's see what we can do. So if suppose is a summation of course A, B, C, D, E, we are taking C, D, E, 5 variables. So when we have 5 variables, till what we can go? We can go till to the power of 4, right? 0, 1, 2, 3, 4. Yeah, to the power of we can go till to the power of 5 minus 1. We can go till 31 actually. So let us see. So we'll not take the 0. Okay, so the group 0 is just only one element, so let us not take the group 0. Let us start with 2, then maybe 2, 3, 4, and let's jump to 9, then 11, 12, and then here 25, 27, 28, 30, 31. So these are the numbers. These are the mean term numbers. Suppose, let us work it out. First thing we have to do is formulate these mean terms in terms of the sequence. So we have, so this will extend actually, so let me extend this. So we have 2 is 0 0 0 1 0, 3 0 0 0 1 1, 4 0 0 1 0 0. Similarly, we have to write down all the min terms. Eleven, 0, 1, 8, 9. Yeah, 12 is 0 1 1 0 0. Then 25 directly. 25 would be your, this is 8, this is 16, 16 and 8 and 1. I hope I am correct here. 16 plus 8 is 24, plus 1 is 25. What would be 27? 16 plus 8, 24 and 3. Then 28 is one more, 16, 24, 28, 20, 30. 30 is 16 plus 8, 24 plus 4, 28, 30. 31 is all ones. Perfect. So hoping I am correct in my conversion. So let us go ahead with this. So whatever I have done, let us go ahead with this. So first is the column 1. So column 1 you have to make, and there you have no G0 is there, so you collect the G1 sequences you collect first. So you have to notice which are the sequences where you have only one number of ones. So this is one, so you have to write 2 0 0 0 1 0. Then you have to put a tick mark, so put that tick mark. So then 4 0 0 1 0 0, put a tick mark. Then no other entries which can come to G1, so you write this G1 here, put a ending line. Then G2, so this is one entry of G2, 3 is 0 0 0 1 1. Then this is another entry 9, which is 0 1 0 0 1. Then remember to put the tick marks, 12 0 1 1 0 0, no other. Okay, so G2 is done. Then you have G3, any entry in G3, yes, this one 11, put the tick mark first, 0 1 0 1 1. This one also 25, 1 1 0 0 1. Any other, yes, this one is there, 28 28 1 1 1 0 0, no other in G3. G3 is done, you put the ending line. Then G4, 4, yes, 27 is an entry in G4. 30 is also an entry in G4. Okay, G5 has only one entry, so let us just not take this 31. So let us not have another group here. So 30 is fine. So 31 we are not taking. G4. So it's ended. So when you have ended, you may not write the ending line also. So now the task starts. Actually, you just have a check whether all the min terms have been collected. So all the min terms must be ticked. So if there is one missing tick, then you quickly recheck whether you have missed the tick or you have missed the term. Okay, so you do that check and you enter that term if you have missed it. Next column 2 you are making. Column 2 you have to start combining. So you look into adjacent columns. So let us see, 2 is here, so where is 1? Where 1 is in the position 4. So let us see where 1 is in the position 4. For 3 you have 1 in position 4 and only one another term is changing. So good, that is what we want. So 2 and 3 can be combined. So you write 2 3 and you write 0 0 0 1 x. Okay, I hope you understand what I am doing. So 0 0 0 1, and whichever bit has changed, I write it as x. Any other combination with 2 9 and 12? No, it cannot. Okay, don't forget the tick. So then you cannot have combinations of 2 with 9 or 12. 4, can 4 combine? 4 combines with, not with 3, not with 9, with 12, yes. So 4 and 12 can come together. So 4 and 12 can come together and it would be 0 x 1 0 0 and no other possible combinations, so you will put the ending line. After that, for G2 and G3 you have to check. So here 3, you see 2 ones are at the this last two positions. So you see where last two positions are 1, in 11 it is, and you can actually take this combination. So 3 and 11, 0 x 0 1 1. Then with others, no, it cannot go. So 11 you put a check, 3 you can put another tick, no problem. Then with 9 is 0 1 0 0 1. So once, note the position of ones and see which among these sequences have the ones in same position. You have in 11 ones in same position, and only another bit is changing. So 9 and 11 can combine. So 9 and 11 can combine, and you are getting 0 1 0 x1, right? Yes. Then again you can combine with 25. So it again combines with 25. 9 and 25 combines with each other, and you get x1 0 0 1. Can it go with 28? No, it cannot. Then you look for 12. So 9 is done, then 12. 12, can it go with 11? No. With 25? No. With 28? Yes. 28 it can go. So you put a tick mark, 20, 12 and 28. 12 and 28, x1100. Everything is done between these two groups. So you end these combinations. Then G3 and G4 you have to look at. G3 and G4, note the position of the ones in 11 and see where such position is repeated. So in 27 it is repeated. So 11 and 27 can come together. 27, and you have actually x1011. Tick mark is important. You can put as many ticks against one sequence, no matter, but at least one combination means one tick should be there. So 27, ticking 27 is more important. So here 11 and 27 is combined. You cannot combine 11 and 30. 25 and 27 can be combined. So 25 and 27 can be combined, and what you get is 110x1. 110x1. 25 and 30 cannot be combined. 28 and 30, 28 and 27, 28 and 27, no, it cannot be combined. 28 and 30, yes, it can be combined. It can be combined. 28 and 30 can be combined. So you put the tick mark and then you write the combination. Yes. Notice once whether there are repetitions within a group. There are no repetitions within a group, so no problem. You don't have to cross anything out. Column 3. So in column 3 you now combine between these groups. So 2 3 this. So note the position of x first. No x in the last position in group 2. So 2 3 cannot combine with anything. So 4 12 x is in the second position. So you note x in the second position in 3 1 only, 3 11 only. But can you combine? No, you cannot combine, because more than one number of bits are changing among the other bits. So you cannot combine 4 12 also. So no possible combinations between the first two groups. Then second two group. So first two group cannot be combined. So you may put a blank here or whatever. You can leave it actually. Then the next two groups. You see 3 11, position number 2 is x. No x in position number 2. Okay, so you cannot combine 311 with any one of the last group. 911, last but one position is x. You look into this, 2527 has x in the same position. It has one also here, this one also here, and yes, 911 can actually combine with 2527 because among the other bits only one bit has changed. So 9, 11, 25, 27, and this becomes x 10 x1, x10 x1. These two can combine with 2830. Let's check. No, it cannot combine with 20 and 2830 because more than one bits are changing apart from this x position. So 9 and 25, the first position is x, 11, 27, the first position is x. Can they combine? Look carefully. Yes, they can combine because only one bit is changing among the other bits. So 9, 25, 11, 27, and you have x10 x1, x10 x1. And then you look at 1228, 1228, can it go with 1127? No, it cannot go with 1127. So then now you are done with the column 2 reductions. Column 3, so these are from the same group, and these, you notice by chance they are also the same combination, so you can cross out one of them, cross out one of them. So now you have, now no further reduction can be possible, so you now check for the unchecked terms. The unchecked terms are this, 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 and this. So there are so many number, 6 number of unchecked terms. Okay, so the final result f will have 6 product terms summed together. Let us start from the first ones. So a dashed, b dashed, c dashed, d. I hope you are able to understand how I am forming the terms. A dashed, b is not there, c, d dashed, e dashed, plus a dashed, c dashed, d, e, plus this one. So this one is b, c, d dashed, e dashed, plus this one is a, b, c, e, plus b, c dashed, e. So you get the final expression. So I hope it is clear to you how to do the Mcclaskey method, and also you have some insight why it is working, because we are taking terms together where only one bit has changed, and hence we can remove that bit from the combination of the terms. And we are doing such combination, we keep doing such combination of terms as much as possible, and at the end we would get the minimal expression. So this is how the Mcclaskey method works, and with these two examples I hope you can form any example of your own. You will be given tutorials also, so you can actually solve for those examples. You can get the reduced expression. Once you get the reduced expression, also try always drawing the circuit neatly, so that also is a practice. So more you draw a circuit, more you will get an understanding how to draw the circuit neatly, so that when you are doing it in the examination, you are not doing it for the first time or the second time, and you will be having a quite a good experience of drawing circuits, and you will be able to draw up a neat circuit which is clear and understandable. So with this I will end this lecture. Thank you for your attention.